Alright guys, so the last video finished on up and we were looking into basically what does the first derivative test mean and how can we use it to find local minimums, local maximums, and even to an extent find absolute absolute max and mins as well. And so we're going to look into an example of how to put the first derivative test into application. The goal for this video is now to take the first derivative test and put it into some application as to what can we really expect while using it. So let's think here for a sec. It's called the first derivative test. So we know right off the bat that we're going to need to take the derivative of this particular function. But specifically, let's think for a second what this function means. X cubed minus 12x minus 5. And our goal is to find the local and absolute extrema for this particular example. Well, because of this function just being a normal cubic function, it has a domain of all real numbers. It's going to go from negative infinity to infinity. So there really is going to be no critical points in terms of where it causes the domain to be undefined or anything kind of like that. And so what we can take out of that is that, hey, the critical points are really only going to be found of wherever the derivative crosses the x-axis or where the zeros of that derivative are. So let's go ahead and find out where the derivative does actually equal 0. So f prime of x is 3x squared minus 12 using our just simple power rules when we know about derivatives. So I want to know when this equals 0. So when 3x squared minus 12 equals 0, 3x squared equals 12, or x squared equals 4, and then square rooting, you get x equals plus or minus 2 in this particular example. So we know the derivative of this function is going to equal 0 when x is positive 2 and when x is negative 2. And this is going to let us know, hey, these are the critical points. Remember, there's two options for critical points, either where it does not exist or where the derivative is equal to 0. So what we like to do when we're using our first derivative test, remember the point is to say, hey, is it positive to the left of a critical point? Is it negative to the left? Is it positive to the right of a critical point? Or is it negative to the right of a critical point? So let's figure out what's happening here. We like to make a little chart, I guess, a little number line at negative 2 and of 2. And then you're basically trying to think to yourself, what is happening to the right of 2? What is happening to the right of negative 2, but to the left of 2? And then what is happening to the left of negative 2 as well? So let's think here for a second. We know what's going to be happening at negative 2 and 2 by specifically just substituting those values into f of x. So when I substitute negative 2 into f of x, and you can kind of do the math on your own and kind of to save some time, we know that f of negative 2 is going to be at 11. So I'm just going to put 11 up here for that, at negative 2. That's what f of negative 2 is going to be. And then for f of positive 2, we can see in this case, once again, you can do the math, and just kind of save some time here. You can substitute it in, it's going to be negative 21. So I'm just going to put negative 21 up here, just so we know what's particularly happening. And so if we want to kind of see what's going to be going on, either positive or negative, we got to kind of see, all right, well, what's happening to the left and to the right of negative 2 and of 2? Well, let's find out here. So I want to find out a value to the left of negative 2. So to the left of negative 2, something like negative 3. So negative 3 cubed minus 12x, which in this case, negative 12 times negative 3, and then minus 5. Well, negative 3 times negative 3 is a positive 9, and so positive 9 times negative 3 is a negative 27. So negative 27 plus 36 minus 5 in this case. Well, negative 27... let's see here, plus 36 minus 5, let's see, it's really negative 27 plus 31, so negative 27 plus 31 is going to give us a positive 4. So at negative 3, I'm just going to put negative 3 right here, is a negative 4. Well, what's happening from negative 4 to 11? It is positive because it is increasing to the left. Go from -4 to 11. It is increasing, so it is positive. Now let's take a value in between -2 and 2. Let's just choose 0 somewhere in between. Well, f of 0 in this particular example is going to be 0 minus 0 minus 5. So it ends up just being -5. So I'm going to put a -5 right here. To go from 11 to -5 is decreasing, so it is negative right there. And then as you're kind of going back up, well, kind of thinking what's happening between the two, this is going to be negative between from -21 to -5, right? So this is still negative. To go from -5 to -21 is still a negative. Don't think that -21 is bigger, all right? So -5 to -21 is still negative. And then to the right of 2, we can just we'll use f of 3 because we use -3. To the right of 2 is 3 cubed minus 12 times 3 minus 5. So you're looking at, what, 27, that's minus 36, and then minus 5 in this case becomes a -13. So let's say just over here to the 3 end up being -13. To go from -21 to -13 is an increase, so that means that it is positive to the right of 2. So let's kind of think of what's happening. I went positive to negative. So if I'm going to the left, going to be positive, and to the right, going to be going decreasing or going down, let's go back and take a look here. Positive to the left, negative to the right, that's a relative max. So we know we're going to have a local or relative maximum at -2. So local max at x equals -2, or in this case we ended up saying the point -2, 11. And then we're going to have a local minimum at x equals +2, or at -2, -21, because we were going from negative onto positive in this case. So it's kind of showing that swoop down at the bottom. And so we finish up kind of the purpose of the example itself by saying, hey, is there any absolute maxes and mins? Well, think about it. This is a cubic. The domain is from -infinity to infinity. Is there going to really be any absolute max or mins? Hopefully you're saying no, because it goes from -infinity to +infinity, so you can't really decide where the absolute max and min are, but we have some local max and some local min somewhere in between, and specifically at the values of -2, 11 and -2, -21, okay? I want you guys to give one on your own. It is the second part of the example in your book, and so give this one a shot. Same goals. G of x is equal to x squared minus 3 times e to the x. When you are solving this, don't forget that the derivative of e to the x is e to the x. You have to use your product rule. Use your product rule to make sure that you come up with this. And then find out, where is it going to be the critical points? Is it going to be the zeros? Where is it going to be specifically about it? Okay? So give this one a shot. It's the answer can be found on page 207 in your books.